So now let's do the opposite and look at a graph and try to find the formula for it, or a possible formula. So there's a couple steps that we do for this. The first thing that we do is we write the factors and their multiplicities. Multiplicities. Okay, so remember the factors, and that's based on the zeros, which are also known as the x-intercepts. Looking at this function, we can see that there's a 0 at -2, at 0, and at 3. So that means that this function has to have the factor of x plus 2, because when I plug in -2, this has to equal 0. And then it's going to have the factor of x, because again, when I plug in 0, it needs to equal 0. And then the factor of x minus 3, so that when I plug in 3, I get 0. In other words, when we define a 0 of a function, we said if a 0 is r, then the factor x minus r is going to be a part of this polynomial. So x minus -2 is the same thing as x plus 2. X minus 0 is the same thing as x. And x minus 3 is x minus 3. So we figured out the factors, and now let's figure out their multiplicities. So again, we're going to have an even multiplicity if the graph touches there, and an odd if the graph goes through at that x-intercept. So in all of these cases, the graph is going through. So that means we're going to have an odd multiplicity. Now there's a ton of odd numbers, obviously, we could choose. But just for the sake of this class, if we're doing odd multiplicities, just have it be to the first power, and even just put it to the second power. So all of these are essentially to the first power. And now we have to figure out, we need to distinguish this polynomial from every other polynomial that has these same 3 zeros. So we figure out what this factor a is. And that's what's going to help us distinguish between, there's tons of polynomials that would have these x-intercepts. But what makes this one, specifically the one in purple, unique? Well, the specific points on it. So, second step. So first step, write each of the factors and their multiplicities. Second step, solve for a. So when you do step 1, always write an a in front. And you do that by plugging in a point that is not a 0. So in this case, they gave us a point, this point right here, which is 1, -3. So that means that when I plug 1 in for x, this function is going to spit out -3. I can use that fact to solve for a. So anywhere I saw an x, I replaced it with a 1, and the output, which again is p of x, I replaced it with a -3. And now I'll just simplify. So I get -3 equals a times 3 times 1 times -2. -3 equals -6a. Divide by -6. 1/2 equals a. So now we have a formula of, I'm going to do this in purple, p of x equals a times x plus 2 times x minus 3. And you can kind of double check to make sure this makes sense. So if I looked at the leading term of what I just found, that would be 1/2 times x times x times x, which is 1/2 x cubed. So that's an odd power function with a positive coefficient, so it should look like this, which is exactly what this graph has for the end behavior. The zeros should be negative 2, 0, and 3. Negative 2, 0, and 3, so that works. So that's kind of a way that you can double check to make sure you've done this correctly. Let's look at another example. Find a possible formula for the polynomial function graph. Okay, so we know we'll start with f of x equals, and then it'll be a times each different factor, and those factors comes from the zeros. So our first zero is at negative 3. So that means this polynomial is going to have a factor of x minus a negative 3, which is the same thing as x plus 3. We also have a 0 at 0, so that's just going to be x minus 0, which is just x. And we have 1 at positive 3. Now we need to think about their multiplicities. So at negative 3, the graph just touches, so that means it has an even multiplicity, so we'll put that factor to the second power. At x equals 0, same kind of thing, so that's going to be to the second power. And then at x equals 3, it goes through, so that would be to an odd power, which we'll keep to the first power. So now to find the a value, we'll use a point. So the point that I'm going to use is going to be the one that they gave me here, which is at 1, 2. All right, let's plug that one in. So I know that when x is 2, or excuse me, when y is 2, our x value is 1. So let's replace all of the x's with 1. And then we'll simplify from here. So this gives me 2 equals a times 4 squared times 1 squared times negative 2, which gives me a times 16 times 1 times negative 2. So 2 equals a times negative 32. So that means that a equals negative 1 over 16. So when I write my final formula for this, f of x equals a, which is negative 1 over 16, times x plus 3 squared, times x squared, times x minus 3.